Hello guys. So I think I am audible. Yeah. So today is the day 4 of NLP, and today we will learn the architecture of RNN and how are the RNN like recurrent neural network works and all of these things. So basically I am referring to this script of Chris Nayak. I think many of you already know the Chris Nayak. He's a very known Indian YouTuber and his content is very good. If you will learn from this Chris Nayak, you will get in-depth intuition. But I will mainly focusing on the upper bound like revision of all these notes of Chris Nayak. So basically this notes is of Chris Nayak and he's a very good talented teacher of India. And I have also following from Chris Nayak from past 2 years and basically learning from all of these machine learning and deep learning things. Because of only Chris Nayak, I am able to know that all of this machine learning algorithm. He's a very good teacher. You have to also follow this. Basically, I will share you a link of this YouTube channel to the Chris Nayak. You can follow him also. Yeah, so let's start from today. Today is my lecture 4 of NLP, and basically we are learning the RNL, like recurrent neural network. So previously we have already learned like bag of bird, TF-IDF, bird to back, average bird to back, and also Python practical implementation also we have done. Inside bag of bird, like inside bird to bag, we have continuous bag of bird and skip grams. We have already seen that like how continuous bag of bird and skip gram will work. Today is the mainly focusing on the RNN architecture, like how this RNN work and all of these things. The first model that the scientists have created in deep neural network, like RNN, which is basically based on ANN, like artificial neural network, which RNN, like recurrent neural network. And we have already done like deep learning playlist. So in deep learning, you have found like RNN, LSTM, RNN, GRU, RNN, bidirectional LSTM, RNN, encoder, decoder, transformer, BERT. These all topics will come under the deep learning. We will learn firstly RNN and then LSTM, RNN, GRU, RNN, bidirectional, like how this architecture are different to each other and how this will work. Now we are using a transformer and BERT and ChatGPT model, which is basically based on this or RNN and LSTM. Okay, so this is the interview question. Like in one of the interview, they will ask, like, what is the difference between train, test, and validation? Yeah, so it's a very simple question. Like training is the data where we will train the model, and testing is basically a testing data. Basically, where we have to evaluate our model, like how our model is working. So training is basically a training data. So at the time of training, we will train our model and testing to evaluate like how our model is working. And the second difference is like what is validation. This is somewhat typical different. Sometimes some candidate will not know. So validation data is basically split is from training data. Suppose you have 100 data point, then 70 like 80% of data points from training and 20% we will take it as a testing. This is basically an ideal situation. You can change it. This is basically hyperparameter. You can also change it, and after like 80% training, you can take it as a 70% of training and 10% data as a validation. And this is also a hyperparameter like validation. And there's some techniques also to evaluate like validate our more validation. So like k cross validation and some also like grid search cvs are there. It's also a randomized search cv is there. So these are some techniques to train our model, you can say that, like this. Mhm. I think you already know like k cross validation. In k cross validation we will take k-fold, like k-fold cross validation. Like if you have a data set, like if we take as k as a 5, then we have to divide this our data set into a 5 points and take one by one as a validation point. And why random forest instead of decision tree? Yeah, this is also a question, like why random forest instead of decision tree? Yeah, so in decision tree, basically our model will be overtrained. In case of overtrained, our model accuracy is very high, but in testing it's a very bad accuracy. So we can say a low bias high variance is there. So to convert low bias high variance into a low bias low variance, we will train a take a, train our random forest. So random forest basically convert our low bias high variance into a low bias and low variance. So that's why we have to use random forest. Random forest is basically a combination of many decision trees, or we can say a low uh, big learners. Yeah, combination of many big learners. Now coming, these are the some interview question I have basically mm, answered you. Now our main focus is on RNN, like why RNN is famous. And this is basically the first model that the scientists have created and got a good accuracy. But after that, they have created changed the some architecture, and now we are using ChatGPT and BERT like model. We have already seen like how transformable, but in transformer basically we have six encoder and six decoder, and basically it's encoder and decoder, number of encoder and decoder is basically a hyperparameter, you can change it. But in ideal case we will take as a 6 and 6. So just the architecture of transformer I've already taught you. You can see my lectures if you want to. The transformer, now we will see RNN, like how RNN works. So in RNN or any model, basically we know that model can't understand English. So we have to convert this text into vectors so that our vectors now can understand the models. So vectors is basically a mathematical expression of our text. And to nowadays we are using embeddings as a vector. So embedding is basically a good vector, basically we can say a good representation of English into a math so that our model can understand easily of that embeddings. So machine learning, birds embedding, and basically we say back to back and average back to back algorithms are there. So now suppose a chatbot is there, you can ask any question and the answer is given. Sequence of bird is very important. Yeah, so sequence of bird means basically if you are not getting a sequence of bird in the proper manner, then there is no use of any model. So to train this model or chatbot, we will use, wait one minute. Hello, हाँ भाई साहब. हाँ बहुत तो अब देखा तू कब कब हम आया तो देखने लगे वो ना. हाँ हाँ अबे तो जरूरत नहीं है, और जब बेचन लगे सो देखने लगे. हम्म, ठीक है. Yeah, so let's continue our discussion. Sorry for the disturbance. Yeah, so we are talking about like language translation from Hindi to English. So suppose if I want to translate my sentence from Hindi to English, then the sequence of word is very important in case of translation, because there is no like one to one mapping is not there. If you want to translate from one sentence to in another language, so the sequence is very important. That's why the transformer like model is very good in that. But now we are talking about RNN is also good, like somewhat they will capture the what we say, uh, they can capture somewhat meaning, or we can say like sequence of word, but they are not good when the sentence length is very huge. If the dependency is from second or third sentence, like my name is Nancy Dangi and I am working as autobus mobility and something like blah blah blah. If the sentence is growing very very huge, then the your model will not work very well. So here the RNN model will fail. At the if the sentence length is one or two, this will work very well. But at the when the sentence length is growing very very huge, then your model will not perfect well. So that's why the scientists now are using transformer like model, so that they can capture if the your length and if your length is also greater than or dependent on 3 4 sentence, then this will work fine like transformer like model. But the RNN not work fine. The first reason is that because there is some what we say very what we say mm, dead neurons, not dead neurons, gradient descent, or we say your like wait, some word is there like your model is not training very well, like penalty, not penalty, something is there. What is this? Gradient descent. Not grow very fast. So yeah, some word is there. I'm not getting that word right now. So like there's dead neuron we can say, but dead neuron is not the correct meaning. Like in RNN, descent, gradient, penalizing. Something is there. I don't getting that word. Yeah, so due to this reason, the like the bait is not growing very very like due to chain rule of differentiation, the problem will occur like your bait is not updating in a good manner, or your testing error is coming very very high, and your bait is not updating well. So that's why your RNN like recurrent neural network model will not work well. So that's why nowadays we are not using RNN. But this is a base of our deep learning, we can say, and every model basically is dependent on this RNN. Firstly, the like in 2000s, before 2017, everybody is talking about like RNN model, but nowadays nobody is talking. But now and after that RNN, they have created a LSTM RNN like long short term memory RNN. This will work fine as compared to RNN, but like after that 2017 they have created a transformer like model, and this is now a very very good model, and everybody is using transformer as a model. But I think in future there may be some new different type of model will come and works very well as compared to transfer also. Nobody knows the future. Like everybody every day a new type of model is coming. Now see the architecture like how RNN will work. Gradient descent. There is something is there. I am not getting that word. In deep learning, I have taught you. Mhm. This is due to chain rule of differentiation and chain rule of the vanishing gradient problem. Yeah. So due to vanishing gradient problem, this will occur. Yeah, RNN like model will not train very well due to vanishing gradient problem. Vanishing gradient problem. Vanishing मतलब vanish very very small changes. Like you all we already know that every model is nothing but a bit matrix is there inside every model. So and your bit matrix will be reinitialized after the epochs every after every epoch. So if we train a deep neural deep RNN network. So after some epochs, the bits of this initial layer will not train very well due to chain rule of differentiation, and we say that vanishing gradient problem, because these model are not good as compared to nowadays like transformer. So the problem is only in RNN is like vanishing gradient problem. Due to vanishing gradient problem, this will not work very well. Now see the architecture of this model. So what happen in RNN basically, we will pass our input and we will get as a output, and every output will pass again through this input, so that like this will train in a good way. This is the first model, and now at the time of the creation of this model, they will get a good accuracy like approx 30 to 40%. At that time this accuracy is very good, but nowadays we are getting it to 90%. And now we are thinking like, yeah, these are good, but in future we will get a more accuracy like 95 or more, maybe greater than that accuracy. Now let's see how this work. Suppose we are using a sentiment analysis, so the food is good and the sentiment of this is positive. So what we have done, we will pass every word at the time frame. Like at the first time frame we will pass the, basically we not pass the, we will create embedding or some new numerical embedding we can done, like bird to bag, average bird to bag is there, continuous bag of bird, or maybe TF-IDF vector, you can do it, anything you can do it, and pass first this this input as a model and say you have to predict it this bird. Like if we pass the, then you have to predict something, and then again you have, what we have to do, like there is four types of RNN is there, like one to one, one to many, many to one, many to many. So we will see like for this every, like for this every model we see, will see like one example of that model. So if we at the time frame of one we will pass the, and we will get some output. So what we have to do, again we have to pass this output and pass food at the time frame of two. Like at the time frame two means at the second time frame we will pass second bird, and also we will have the previous input like the we will not have the, but for the we have some output like in mathematical form, so that this will represent the. And again what we have to do, at the time frame of t we will pass edge, and for we have already the context vector of the food, and then the context of the food is also all passed to the at the time frame of third, or we can say at the time of t equal to 3. And so this is the process that we have to done for every time frame, and we will also pass the context vector of the previous sentence, so that our model will train as good as we want. Yeah, so that's it for in RNN. And we have to also like see that like there's four types of RNN: one to one, one to many, many to one, many to many RNN is there. Yeah, so now we will see example for everyone. So what is the example of one to one RNN? So in one to one RNN, basically we will pass one input and we will think our model will also predict one output. So suppose in that basically in one to one we will say we have one input like number of rooms, and we want like what may be the price of that room. So basically this is a one to one mapping. So in that case we will use one to one RNN. And the second type is one to many RNN. So in one to many RNN basically what is the example? So in one to many we can say, we will say to model like create a song. So in that what we have to do, only say create a song or anything, and this will create a whole song for you. Or we can say create something like music generation, text generation, we can say. In many to one basically we will pass many input and say to model predicted only one output. So in that basically sentiment analysis we can say. This is the example of many to one, and many to many. Basically, we will pass many input and we will say predicted many output, like language translation. This is the example of many to many RNN. So this is for RNN and how this will work. We already seen that in embedding. Like firstly, the Google Net have this created a embedding model, and they have decided a dimension of 300. And nowadays we are creating a dimension of 1000, like 400, something like that. And this is the first model that were to back, and basically at the time they have created 300 dimension model, and this is working fine at the time of the RNN, and this is also working very fine, working very good. But the problem is only there's the like context problem. If we have a 2 3 sentence length, then whom I is referring, we can't, sometime it will predict it, but sometime it will not work well. So that's why we are not using RNN as a model for a good accuracy. And this is for many to one. We have already said we will pass many input like sentiment analysis, predict next day sale. This is the exam. Or in many to many, so language translation, question answer, chatbot. These are some example. For propagation and backward propagation, we have already seen that, like how this will work. In for forward propagation, basically we will assign some bits and multiply and get some output, and after that getting the output we will find the error, and after finding the error we will train, like apply some Adam optimizers, activation functions, so that the bit matrix will be changed, and get in backward propagation we will apply some like activation function, or we can say optimizers, so that we will re reinitialize our bit matrix, so that we our error will be as low as possible as can. And forward propagation in RNN, we have already seen that. So in forward propagation, basically we will pass our input and apply some bit matrix, and this bit matrix in multiplied, and then we will get some output. And the second time frame we will again pass this input, and we have already the output matrix, or we can say output context vector of the previous layer. That's how we will apply it and get some error. And for this, if we apply a multi-class classification, then we can apply a softmax activation function, and if you are using binary, then we apply a sigmoid activation function. And that's how it will work. Yeah, that's it for RNN. I think you will get understand it. This is basically very very simple. I think I am explaining in a very good way. That's how RNN will work. So now revise, I will give you some revision so that you can understand it in very well manner. So in basically RNN, what we have to do, pass one input, and then we will get some output. So this output along with the second input is passed, and the third time frame we will pass again third input, and we have already the output vector of the previous layer. So in the third, in at the time frame of third, we have our context vector of first and second also. Basically this is a combination of first and second output vector. So there's some mathematical calculation is already applied inside this RNN, and they will predict something, like give you some bit matrix, and this bit matrix and along with your new input every time we will pass it, so that our model will work very very well. That's how it will work. But if you in that, basically the bidirectional is not there, so our model can't understand the previous bird. Like suppose I said bull is going, you can't understand like in which sense I am talking. Like I am talking about animal or market. If I say bull is going high, then you are able to understand, like, yeah, he's talking about stock market. So in this RNN the bidirectional is not there, so this will not work very well. Like he don't know like the what may be the like next word, or so the context is not getting captured in RNN very well, so that's why this will not work very well. So now we will learn in the second lecture. In the next lecture, we will learn about the bidirectional LSTM and LSTM model. Like LSTM is very good as compared to RNN, and LSTM is nowadays we can use it. Sometimes it will work very well like LSTM, but nowadays we are using transformer as a model. So let's see like how LSTM RNN will work. Okay, thank you guys. That's it for today. I think LST like RNN is done. Let's meet in next lecture and learn about LSTM. No, yeah, LSTM. So in NLP, this is the lecture 8 of 6 done. In 7th lecture, this is the 6th. So 7th is there. This is not. This is LSTM RNA. Yeah. So in the next lecture, we will learn about LSTMRNN and also see some interview question like distribution about. Okay guys, thank you guys. Let's meet in the next lecture. Please subscribe my YouTube channel. Basically, I am getting all of this material from Krishnaik. I think you already know that. Please subscribe my YouTube channel so in future I may be also a good teacher like Krishnaik. I am also very motivated by Krishnaik to create all of these things. Thank you guys. Let's meet in the next lecture. Jai Hind, Jai Bharat.